Okay, so today we're talking about combinations. So this is, we're getting to some tougher stuff here. So today's probably the toughest lesson maybe we've had all year, definitely possible. Okay, so remember the idea of a permutation where order matters. So if you had those 5 picture frames, you want to see how many different orders, it'd be 5 factorial, 5 times 4 times 3 times 2 times 1. I call that the slot method, right? So you just fill in the slots and you got it. If order doesn't matter, then to choose some number of individuals in a group, then that's a different question. You have to use a different answers. For example, so say Mr. Wilcox decides to randomly select 3 students, homework papers to grade each day. Puts 28 names in a hat, mixes them up, draws 3. That's great. How many different ways can he choose 3 students' papers to grade? So, maybe he chooses, it's tempting to use slot method, right? 28 times 27 times 26, 19,000 ways. Well, does order really matter in this situation? So let's say he picks those 3 people in that order. Is that any different from getting that or that? Aren't those really all the same there? So how many different ways can he pick the same 3 students, right? So order doesn't really matter in that situation. You're picking 3 out of 28 where order does not, you're not ranking them. It's not like you're picking the first student, oh, the lucky first student, no. Like they're just picking 3 students, right? So there's lots of different ways to do that. There's 6 different ways actually in that case. So how could we use that? Well, we could say 3 times 2 times 1. There are 6 different ways of doing that. This is getting into the kind of the reason for the formula we're about to see. Same applies to any 3 students, that's true. So there's 6 ways to group any 3 students. So you could do that number, the 19,000 number, divided by 6, right? Because there's 6 ways you could group each pairing there. So 3,276 different ways. Still a lot of ways, but not nearly 19,000. So that's going to be the combinations of 28 students taken 3 at a time. We write that as 28 choose 3. So C stands for combination when order does not matter. That's the important part of that combination idea. Different than permutation where order matters. Some people write it like that. I really like the 28 choose 3. It's the way the calculator does it. That's the notation. NCR. N is the number of individuals. R is the number that you're taking or choosing at a time. And so again, so like if we typed in our calculator, if we typed in, let's go menu, probability combinations. So what was that? 28, 3, 3,276. That's the number that we got doing that. It's a different way of thinking about it, but you're dividing the permutation by the 6 in this case. There's 6 different ways to group those folks. They're just kind of getting at the idea of the formula. This is the formula. You don't need to memorize it. We don't really use that. We're going to type into our calculator and let the calculator do the work. The hard part is recognizing it and using it. Again, this is getting tough though because of the types of questions. The questions get very involved. Here's an example. In the New Jersey Pick 6 Lotto game, a player chooses 6 different numbers from 1 to 49. The 6 winning numbers from the lottery are selected at random. If the player chooses all 6 numbers, they win the jackpot, which starts at 2 million. How many different possible sets of winning numbers are there in the New Jersey Pick 6 Lotto game? Okay, so is order important? I don't know if you've ever seen a lotto drawing, but they usually have ping pong balls. They come down a chute. It doesn't matter the order. As long as you have picked those 6 numbers, you're going to win the big prize, right? So order does not matter. So we're picking 6 out of 49 in this relatively simple situation. So it should be, so NCR, you can actually type it if you prefer. NCR, was it 49? I forget. 49. So 49, comma 6. There should be, oh my goodness. So 13,983,000 different ways of winning the lotto. So the formula NCR, they used the formula 13,983,000. So different sets of numbers for this game. So that's the chance you have of winning. So you pay $2 for a ticket, you have 1 in 13 million shot of that. You can also calculate a solution using the how-to box. So you could use the formula if you wanted to, but again, NCR is going to be the way to go there. I'm not worried about that method there. The hard part's just setting it up. Okay. The probability of A occurred is the probability of the number of outcomes in A, so success on the top and the total number of outcomes in the bottom. So that's important as we get to tougher questions, because we might have to put total on the bottom and what we want to happen up top. Okay, so by matching all 6 numbers, because the winning numbers 1 in 49, so 1 in 13 million or 0.00. Wow, you look at a decimal, it's really bad. But I like the way they notated that. Do you see on the left there? So the notation is, the denominator is all the different ways, right? So that would be 49 way, choose 6 of them. But there's only 6, up top is the winning, right? Well, how many winning balls are there? There's only 6 winning balls. You want to choose all 6 of those. If you want to think about it this way, this would actually be a cool way to think about it, times, you could put the amount of chance of losing here. So how many losing balls are there? If there's 6 winning balls, there must be 43 losing balls, so 43. How many of those do you want to choose? You really want all 6 winners, so we want 0 of those. You could actually type that in, and this guy right there is equal to 1. To make sense, so this guy is really 1. So it doesn't affect anything there, but it's actually a deeper way of thinking about this, but the denominator is the total. Those are all the possible ways that 6 balls can be chosen. Some of them might be winners, some might not be, but there's 13 million different ways that could happen. So that's a good way of thinking about this. It's a very small chance, that's for sure. There's 28 students, so it's class 12, 16 are seniors, 12 are juniors. Suppose he selects 3 students, homework paper to grades, use a combination that all 3 students are juniors. So let's just try this. So let's try to think this through. So we've got 28 students, so 28 students in the class. Order doesn't matter in this problem, I'm pretty sure. So we're going to choose 3 of them. So that's all the different ways that can happen. But really, up top, we really want to pick, there's 12 juniors, right? So we want to pick 12. Out of those 12, we want 3 of them to be juniors. I think we want all of them to be juniors. So this is juniors up top. If you wanted to, if this would make more sense to you, you could actually do seniors here. So there would have to be, 16 seniors? But we want to choose 0 of those. That part is equal to 1. So that part is 1. So it's not going to affect your calculation. You don't have to include that. But then you would just type that in your calculator, right? So you get your calculator out, control divide. In the top, NCR 12,3. NCR, and there will be 28,3. So 55 over 19, or, oops, 0.067. So there's a 6.7% chance that all of them are going to be juniors that he picks for homework. Let's see if they did the same way. And they got that same answer. There you go. There's about a 7% chance that that will happen. We could have used, this is just a different way of thinking about it. I don't know if it'll help your understanding. It might. So you could actually do it this way. I think this is a more dangerous way to do it, but it's possible. So we want to choose 3 juniors. So the first student's a junior, the second student's a junior, given that the first student's a junior. Third student's a junior, given that the first 2 students are juniors. So put all that together, it'd be 12 divided by 28 times 11. Once you've chosen the first, there's 1 less person, so 11 times 27. That's interesting. You can actually do it that way. Again, I would not do it that way, but you could. It's possible. It's weird in probability. Sometimes that kind of stuff works. Okay. Airline just finished training 25 junior pilots, 15 are male, 10 are female, to become captains. Unfortunately, only 8 captain positions are available right now. Airline managers announced they will use a lottery process to determine which pilots will fill the available positions. The names of all 25 pilots will be written on identical slips of paper, placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been chosen. A day later, managers announced the result of the lottery. Of the 8 captains chosen, 5 are female and only 3 are male. Some of the male pilots who are not selected suspect the lottery was not quite on the up and up. It was unfair. How many possible groups of 8 captains can be selected? Okay, so that's relatively easy, right? So we have 25 pilots. We're choosing 8 of them. Whatever that number is the answer to part A. Whoops. Find the number of ways in which a fair lottery can result in 5 female and 3 male. Okay, so this is a much tougher question. So my denominator would be 25, choose 8. That's my denominator. That's my total, right? But here on the left, and maybe this helps. So this is like, I'm going to put M there for males, and this one's going to represent the females. We're going to multiply these two. So it says there are 15 males, I believe. So 15, choose, I think it was 3 of them. And then 10, choose 5. So 15, choose 3. 10, choose 5. So that'll be, that should be the chance. So you would type that in your calculator and get part B. Let's see how we did on the first 2 parts here. So there's the probability of the first one. Just type in 25, choose 8. Next one. So let's do that one. So I wonder if we have to divide that first one by females. This is the question. Find the number of ways. This was not, I'm sorry. They were just finding the number of ways. So it's just the numerator, right? Success is the numerator there. So I did a denominator. They didn't say what's the probability of that happening. They said just what's the number of ways. That's the number of ways that would happen. Sorry, I didn't read the question carefully. I thought it asked for a probability of that happening. Part C, find that a fair lottery result in the selection of 5 female. So that's asking the next question, which is take that and just divide it by 20. That's what I had. I thought part B was part C. I was answering the question for part C. And if you typed on your calculator, you get 0.106 or 10% chance. So that could happen, right? 10% chance. Find the probability of fair lottery results in the selection of 5 or more females is 0.1281. Is there convincing evidence the lottery was carried out unfairly? So typically we want to see like 5% or less for it to be really convincing evidence, like, man, there's something unusual going on there. There's no way we got those results by chance. 12% of the time, this will happen by chance. So I don't think there's not convincing evidence right now. We don't have enough evidence to prove that. Okay. Sum of the ends is equal. That's true. Okay. How do we calculate the probability of selecting 5 or more females of the preceding example? So this is something they did not tell us. So this would be pretty tough. So they found the probability of 5 and 3. That's what we figured out, that first part. Then they did 6 and 2. Then they did 7 and 1. And then they did 8 and 0. So 6, 5, or more would be doing that thing 4 times and adding up all those probabilities. That's what that would look like, exactly like that. I love they showed the work there. And they added those up to get that 0.12. Because the first one was about 10.6, right? 10.6% chance of happening, just that what actually happened. They were trying to find out, well, what if it was even more extreme than that? We do that oftentimes in stats. Okay, so Janine wants to set up a playlist of 8 songs on her phone. She has 50 songs to choose from, including 15 songs by Taylor Swift. Janine's device won't allow any song to appear more than once in a playlist. It's important. How many different sets of 8 songs are possible for Janine's playlist, assuming that the order of the songs doesn't matter? So you've got different sets of 8 songs. So 50, choose 8. So 50, choose 8. You type that in your calculator and see what you get. How many 8-song playlists contain no songs by Taylor Swift? So now we don't want to have any of those 15 from Taylor Swift. Okay, so my denominator is how many? So I don't need a denominator. Okay, so how many? Not probability. So how many songs? How many 8-song playlists contain no songs by Taylor Swift? Okay, so I want to have 35 or the number of, so I want to get all 8 of my songs from those 35 non-Taylor Swifties. And then I want to, of the Taylor Swifties, which are 15, I want to choose 0 of those. By the way, this part's equal to 1. So right here, this is equal to 1. So I guess I just have to do that first part. So that would be the answer to the question. On our phone, select an 8-song, play at random. What's the probability that none of the 8 songs is by Taylor Swift? So now we're talking about probability, right? So we just take that and divide by 50, choose 8, right? That'll give you the probability of that happening. Find the probability exactly 2 of the songs on the playlist are by Taylor Swift. So now you would change this slightly, right? So we still have this probability. So we still have 50, choose 8 in the denominator. In the numerator, we want to get 2 songs of the 15 by Taylor. So 2. And then of the 35 non-Taylor Swifties. So we're going to do, we want to pick 8 songs. So this has to add up. So the 2 and 6 add up to 8. That's good. And so you just type that in your calculator like that and you get the answer to those. Okay, that's your lesson for today.